Thank you all. I am definitely the ring-in. The last time my family owned sheep was 120 years ago when they moved from the Isle of Man to New Zealand and to Australia. But the big but here is we have been in deep conversations with the industry for the last 3 years because of a critical workshop, much similar to this, albeit it was at the university in fancy buildings with digital television screens on the wall, with MLA, Andrew, Jane Kellogg, and a bunch of other interested young producers like you who were looking for innovation. And the innovation that we brought from the Centre for Nanoscale Biophotonics, from the Davies Livestock Research Institute at the University of Adelaide, was what can we bring to this industry that already exists in defence tech and med tech, and simply flip it over to answer the same questions that the Australian Defence Force are asking today and that we are trying to answer in medicine for the treatment and management of your health. So I am going to make your brains hurt a little bit today, but hopefully in a good way, to open up to both educate you on what the latest in pain medicine is today for us as humans. And if we can get our head around that as a production industry now, we can leapfrog 30 years of human medicine mistakes to get those productivity benefits into your animals really, really quickly. 30 years of mistakes that we can leapfrog today. So, what is today's pain medicine? It is based on a theory that was proposed 400 years ago by René Descartes. We have the best pain medicine today is the oldest medicine that we use. It is morphine. It is a 2,000-year-old medicine. That is the best that we have today. The newest we have is 40 years old. The newest human pain medicine is 4 decades old. And basically we are dealing with a model that says something is detected, it's conducted throughout our central nervous system, it's recognised within our brain, and we do something about it. Now, Descartes used fancy terminologies like levers, pulleys and spirits and particles of sensation to make those measurements. We now talk about that as neurons, neurotransmitters and ionic potentials within the brain and spinal cord. We have prettier pictures than Descartes had, but we are still basing that fundamental building block of what pain and the brain operation is 400 years old. So, to give you an idea of how good we are at human medicine for the measurement of pain, if anybody ends up at the Royal Adelaide or the Lyle Mac and you are in pain, you will be asked on a scale of 1 to 10 how much pain you are in. You are asked that question. That is the best medicine that we have for measurement of pain in humans. Trick for you, if you say less than 4, you will get Panadol or ibuprofen. If you say more than 4, you will get morphine. Say more than 4. The point here is that we ask you on a scale of 1 to 10 and we bring it down to a binary decision, paracetamol or morphine. That is as good as pain medicine gets for the human. The problem is we are using the frontline treatment, a 2,000-year-old drug, and the newest one is 40 years old. We have got it wrong. The current fundamental building blocks of pain and pain medicine in humans are wrong. We have got this idea of transduction, conduction, transmission, perception, and then the modulation of the pain experience. This means that when we start talking about pain medicine for us and for our animals, the assumption is there's one drug that will fix all problems. The problem is that's not the case. We do not have a pain switch for a switch for pain in either humans or animals. This is because when we deal with injury, whether that is a human injury, an incision, a burn, a fracture, or we're dealing with a husbandry practice, mulesing, tail docking, castration, these all drive an injury danger response in the periphery. Yes, we use nerve blocks. Yes, that stops the transmission of that pain signal via the direct wiring system of the body. But these danger signals float around. We don't ever actually stop the danger, the molecular danger signals, these things that are released by damaged tissue, actually getting into and modifying the brain function. That means that we use a great array of fancy medical technologies in human medicine, and we've adopted many of those currently into animal practice, but they do absolutely nothing to this central sensitization that occurs because of these danger signals. That means we're doing a lot in human medicine to stop pain around the time of injury, around surgery, and you may then get some help with your chronic pain, which will develop about 30% of the time. At the moment, we have some products for husbandry practices in livestock management. We have nothing to touch the chronic pain that will be present in the livestock. So, what's this mean for humans? We have a $139 billion cost to our society because of untreated chronic pain. That comes from increased frailty, increased access to health services, depression, anxiety, all of those things that come along with it. Plus, we have a problem. Chronic pain is actually a problem predominantly of females. All pain medicines that exist today were developed in males and male animals. We have tried to treat a female problem with male drugs. Who knew medicine was so clever? What does this look like in terms of the burden of disease that we have in human medicine? That square there, underneath that, is the entire burden of disease that we have for human medicine across the world. More than 3/4 of the burden of disease that we have for human medicine has pain at the heart of it, as a symptom of or a direct contributor to it. That's our medicine, and we have 77% untreated, let alone in the livestock setting. So, this is not all doom and gloom. Human medicine has failed in its ability to address this massive pain epidemic, that, as we call it in the industry. We can learn from the mistakes of human medicine to flip those innovations to actually make a change in practice in livestock very, very quickly. And these changes not only will be an underwriting of social license, but there is a productivity upside if you don't have animals that are in pain, because suddenly their reward systems are switched on. They're more psychologically resilient. They'll eat the right foods when you want them to eat it, and they'll actually put on beneficial weight. So, what are we now thinking about pain in human medicine, so to get you thinking about pain in a new way, and we rewrite the past 400 years of mistakes? We need to start thinking about pain in 4 dimensions. What I mean by that is, if you have a sore big right toe, it may not be that the problem is in your big right toe. It may be that it's in your brain, in your spinal cord, or in some other factor. So there's 3 dimensions to that pain. It also means that what you did 2 years ago may actually be impacting your pain that you're experiencing today. If you are a Afghanistan returned warfighter and you've had significant PTSD, you have got a very, very different baseline propensity to have exaggerated pain. If you are a sheep that's had a poor mothering experience because you're a merino, maybe your brain has developed differently to be less resilient to pain. And so I'll unpack a bit of that with some of the pretty pictures that we've been generating recently. This is topical now. It's topical now because the International Association for the Study of Pain has just redefined what pain is. Pain is not just the sensory ouch component. Pain is actually sensory and emotional. And it's a complex interaction between the two of these. And that is, for us, it means that if we have an emotional experience, it is exactly the same thing as if we've gone and stubbed our big toe or hit our hand with the hammer. The key part about this new definition that acknowledges the complexity of pain from the ISP is that for the first time, they have now articulated down the bottom here, this matters for both humans and non-humans. Now, what they say is non-humans is everything else, including animals. For the first time, the international pain body has acknowledged that animals can experience pain last year. Now, you may go, why the hell have they taken that long? Because science and medicine is slow to adopt new practices. We need to acknowledge that medicine is not all fancy whiz-bang things. We are a slow-moving community. Let's take advantage of that in the fast-moving ag space. So what are the implications for this? We now know what pain looks like at a molecular and cellular level. We can take brains and spinal cords of humans or animals, and we can say definitively, has this brain had pain? Has this spinal cord experienced chronic pain? And you get pretty pictures like this where you see cellular adaptations. There are structural changes. So going back to that concept, is a single drug ever actually going to undo all of these structural changes? No. There's no single drug that will ever do that. However, there are things that we can start to do to stop these changes occurring in time, which is why we're talking about pain in 4 dimensions. So what does this mean? This means that we need to start thinking about how to bring resilience and change in the physiology of our animals and us to stop the transition to chronic pain and chronic changes within our central nervous system. So we now know that there are specific cells that change over time and remember things long term. And the key part about this change in the brain is that we now know it's an immune organ. There are plenty of immune cells within the brain and spinal cord. And if we target those immune cells, they're the ones that remember things for decades. Annoyingly, but opportunistically, if we train them the right way, you can actually get the brain immunology to work in your favour so that then we don't get the generation of chronic pain. So the past hypothesis was you've got an animal, you do some intervention, some husbandry practice, you give it a medicine. We think that we're doing a good thing to that animal. We assume we're doing a good thing to the animal because it says it's pain reliever on the box that we've just given it. We have no idea what the long-term consequences or benefits to that animal are yet because we don't have the measurement technologies available. Now, this was the case in human medicine before I moved back from the States 15 years ago. 15 years ago, if you were going into the Royal Adelaide Hospital, you'd be given a medicine at the time of your surgery and good luck afterwards. That meant that about 40% of people coming out of the Royal Adelaide Hospital, world-class facility, would end up with chronic pain after their surgery. You would end up with this pain transitioning from a site of injury. You'd end up with this central sensitization. It was your brain and spinal cord that were remembering this, but your periphery was all healed. And so you'd go back to the doctor and say, my big left toe still hurts. There's nothing wrong with your big left toe. Go see another doctor, and you end up in this cycle. We now know that that is actually within the brain and spinal cord, and it can be treated if we get the right medicines in at the right time. So what do we do now in the Royal Adelaide? When you get a medicine for your pre-med surgery, you get an additional special medicine that only the Royal Adelaide will give you. There are plenty of other places adopting it around the country, but it was a simple event like this, except rather than you being there, it was a bunch of anaesthetists and general practitioners. And we told them this story and they said, well, that's an easy adoption we can take. We can give a medicine at the time of injury, surgery. It blocks the transition from acute to chronic pain because the danger signals of the surgery never get detected or remembered by the central nervous system, the brain and spinal cord. And we don't end up with the development of chronic pain. And lo and behold, Royal Adelaide Hospital has some of the lowest rates of chronic pain after surgeries when you look at the Australian standards. So what does this mean for our animals? It means that absolutely we want to be doing the best thing we can do for the acute injury-induced pain at the time of a husbandry practice. But is there something extra that we can add into that to stop the body detecting and remembering this long-term pain change? Are there other things that we can be thinking about in creating a resilient animal that can actually build the structures within the brain and spinal cord? So adding on to what Jason's saying with his cards in his deck, I've got a couple of extra cards up the sleeve for benefits. Those extra cards would be actually realising those animals out there, they've got a very powerful computer as part of their head and spinal cord that you can start augmenting. And I've got 10 minutes. Still going? Good. So what can we do? And can we actually see this benefit change actually measured in livestock? So we've done some experiments already with some boys down at Bordertown, the Douglas boys, and they have a program where they change the weaning practice of their lambs. They work the animals through the yards a bit, they work them with the dogs, and basically from me as a fundamental neuroscientist, what I'm seeing there is a change in the mothering practices and the developmental brain potential in those young developing lambs. So what we have is, rather than lambs going off and getting separated from mum straight away, at a point in time when the brain is developing and the emotional capacity of the brain is developing, that we know from human brains, we can then look in abattoir at the Douglas boys' brains, their sheep brains, and ask the question, do these brains have the capacity in terms of the structures, the cells and the makeup of their brain to actually process information around emotional challenges? On the right here, up the top, not showing up so well, but in the red, you'll see that there is a little hook shape which is about a third of the hook shape that you'll see in the blue structures. The difference between these two lots, these are sheep brain run on histology in my laboratory. What you can see here is that normal weaning ends up with about a third of the number of cells in this key brain region called the hippocampus. This structure is responsible for the emotional processing capacity of that sheep, whatever that means for a sheep. But for us, that is a depressed brain at the top. Down the bottom, this is probably our brains. So the fact that we're now actually able to see a simple husbandry practice leading to a threefold increase in the fundamental building blocks of emotional processing in these sheep by a simple modification of weaning practice, that changes the life trajectory of these sheep. We would hypothesize that if these animals were put in any psychological or environmental stress, they would have the emotional capacity to start making the right decisions as to what to do next. Whereas the other ones, they'd go, crap, too bad. We'll give up, we won't walk as far, we won't make the right decisions if food's even put in front of us. Those animals at the top, their immune systems will respond detrimentally to challenge if they are stressed. That means those animals at the top would likely have higher rates of infection and poor response to even vaccinations. And we know that because if we look at humans in these situations with the same type of brain structure deficiency, we can see that in human population. So all of these benefits that we've now identified out of a short 6-month project with those Douglas boys, we've now taken 20, 30 years of human medicine and applied it in a very, very quick time to say, your weaning practice looks to be better than standard maternal separation practice. So what's stopping us actually taking this to the next level? We can't just go on a women a prayer and say, yep, those sheep look better than those ones, because it's so subjective. We need hard numbers. The beautiful thing about the genetics we've been hearing about, hard numbers. But how are we going to inform the genetic selection as we go into complex traits like behaviour if we don't have a hard behavioural number or a hard pain number to actually align with that? Exactly the same problem in human medicine. I showed you before, we measure pain by asking you how much pain you were in. If you are a child, you do not get analgesics. Modern practice in Australia for child surgery only started using analgesics in the year 2004. Analgesics for surgery in our children, let alone the understanding of now an ageing, dementing population who are unable to communicate. Today, if you cannot respond how much pain you are in, you are unlikely to get an analgesic. That means if you're unconscious, you probably won't get an analgesic. If you're a child, you probably maybe now get an analgesic, or if you're dementing, you definitely won't get an analgesic. If you're an animal, we have to look at you and try and determine if you're in pain, or we go, you all get analgesics. And actually, maybe we're not giving the right analgesics in the right way. We need to have objective measurements that allow for the measurement of, do you have pain? How much pain you are in, and have you ever had pain before? So, at the moment, we're just probably throwing a heap of money at a problem which is a problem. But we may not be throwing good money after a bad problem because we're not objectively measuring it. Because in this population, if we all end up at the Royal Adelaide today, and you all need a dose of morphine. I said to you, it's the best drug that we have. Unfortunately, upon the first dose of that morphine, half of you will get no beneficial analgesia from that morphine because it's a shit drug and it's the best we've got. So when we start throwing multiple nerve blocks and anti-inflammatory agents at our livestock, the assumption is they all work because it's fantastic. These drugs are great. Well, they're pretty good drugs, but we can't assume that the response is 100% across the lot. Should we actually then be thinking about specific drugs for specific animals? And by the way, these drugs were developed for males, not for a female predominant flock. Other point is, we're dealing with a flock that is testosterone depleted. So thank you. The flock that is testosterone depleted and castrated, we are dealing with a brand new neuroscience no one has explored because there aren't too many eunuchs walking around these days. So thank you. Yes, any volunteers? Right. We do not have the science to understand how to manage pain in a castrated sheep. That is the fact today. So there is a huge opportunity. If we can learn from livestock to then apply back to humans and humans back to livestock. So what's the future? The future is we are at the point we can now measure, do you have pain via simple blood test? We can now ask the question from spinal cord samples and from cerebral spinal fluid from patients, have you ever had pain before? Now, those two tests alone are powerful because they allow us to now start asking, does this drug work and is this drug better than that drug for acute pain to chronic pain relief? It also means at line speed in the abattoir, we could start asking how many of these carcasses have experienced chronic pain in their lifetime. Suddenly you can start creating a quality control on, yes, I used my X drug for whatever procedure it was. Well, did it work? To now start saying, well, yes, I did use this drug, and here are the other numbers that I can back that up to say, yes, this is better, which will then feed forward into genomic selection for animals that are resilient for chronic pain and for positive affective state. So what's this mean for genetics? I don't want to give you too much on the detail here. I want you to understand there are hundreds of genes and proteins that are involved in pain processing alone. We know what those genes are from human pain medicine. I bet you that some of the genomic selection that's already been done may have accidentally, sorry, but it's accidental, included that resilience factor into it. Imagine what you could take from the wealth of genomic information in mental health and pain relief, positive affective state, resilience, heat stress, the list goes on, which we know for human medicine, and flip it straight into livestock genomics. All of that is untapped in an intentional driven selection program. To give you an example of how rapidly this is moving, this is a figure from a mate of mine, Ted Price, who's in Dallas. He's just identified all of these fancy colours. Those are all new genomic targets that weren't realised in human medicine 2 weeks ago. For human medicine, we haven't done this kind of research in the livestock yet, but with MLA support and other support, thank you Salrec, we'll hopefully do that in the next couple of years. Why is this important? We know that chronic pain in us is dependent on 65% dependent on genetics. 65% of your likelihood for developing chronic pain is already in you and was in your parents. If we can identify what those key traits are for the livestock, we can create a pain resilient and critically chronic pain resilient phenotype. We don't want no stress. We don't want no pain. Acute pain and acute stress are actually good things because it teaches them and teaches us what not to do. We just don't want the long-term stress and the long-term pain because they serve no biological process whatsoever. So where are we heading? Well, it means that if we have objective measurement and we start to have these better drugs that are optimized through objective measurement, we can now start making the genomic selections that are right, and we can start making the right medicine selections that are right. We can also start asking what are the simple practices, husbandry practices, simple weaning practices that will change the trajectory for the animals lifelong. At the end of the day, these are an untapped productivity benefit that many of you would put down to, well, that's just good yard work, that's good stockmanship. Those things actually probably are real, but we can now probably put a number onto them if we can get the conversion of med tech, defense tech into ag tech right. So what's the future? Life well-being and health, welfare, are two big things that are, I would say, suboptimally available in human medicine, let alone in livestock production. If we look at it from a productivity standpoint for us as humans, there is a $139 billion productivity gain for the country if we can get pain fixed for us. I won't challenge Jason on his $1 billion benefit of the extra lambs on the ground, but I would say that if you had better lambs on the ground that also didn't develop chronic pain, you're also then looking at less costs to your businesses when you do then have those animals on the ground. So this workshop, I hope it's not the last one, Andrew, because last workshop we had 5 technologies identified that could be translated from medtech out of conversations that drove out of that workshop. If we could get 5 again just from this workshop, the opportunities are massive. So thank you, and I'm here all day, so if you want to talk to me later on, because I know I've run out of time, thank you for keeping the time. Thank you very much.